We are given that an object is dropped from 128 feet. Using this information, we can develop a position function. So, S of t is equal to negative 16 t squared, which is half of the acceleration of gravity, minus v naught, or initial velocity of the object, times t, time, plus 128. Negative 16 is in meters per second per second. V naught is in meters per second. 128 is in simple feet. So, the initial velocity, because we are given none, is assumed to be 0. So, we can cancel v naught out of our equation. So we are left with negative 16 t squared plus 128 is S of t. We are first asked for A, when does this object hit the ground? To find this point, we set S of t equal to 0. So 0 equals negative 16 t squared plus 128. Subtract 128 from each side. Divide by negative 16. Take the square root of that function. That's how you get t. T where S of t equals 0. So, putting that into our calculator, square root of 128 divided by 16, because the negatives cancel out, is about 2.83 seconds. So that is part A. Part B is what is the instantaneous velocity when the object hits the ground. So now we must get the velocity function, which is the derivative of the position function. So v of t is equal to negative 32 t, and because we have no velocity, our initial velocity, we are left with just negative 32t. So multiply negative 2.83 times 32, negative 32, gets us, so v is about radical 128 over 16 is equal to negative 90.5, roughly. Thank you. We are given that a coin is dropped from a height of 750 feet. So first, we can develop a position function. S of t is equal to negative 16, which is half the acceleration of the gravity times t squared, minus v initial times t plus 750 feet. So v initial is in feet per second, while as negative 16 is in feet per second per second. That is how the units come in for t squared and t, respectively. As we are not given v initial, it is assumed to be 0, so that's part of the expression. Cancels itself out. So we are now left with S of t is equal to negative 16 feet per second squared times t in seconds squared. plus 750 feet. So, we also probably want to get our velocity function. So, v of t is equal to negative 32 feet per second squared. It remains the same units, regardless of the derivative. So, part A asks for the average velocity on the interval 1, 3. So the average rate of change from 1, 3. So, and this is times t in a second. So, if we plug in 3, so average rate of change is f of b minus f of a all over b minus a. So, f of b would be negative 32 times 3, which is negative 96, while as negative 32 times 1 is just negative 32. So f of b minus f of a all over b minus a. So that is all equal to 64, or negative 64 over 2, which is negative 32. So that is the answer to part A. So 32 feet per second. Sorry, this does cancel out. Or with the seconds here. Part B asks for instantaneous velocity when t equals 3. We just solved that with f of b, so now we know that the instantaneous velocity given by this function at f of 3, or v of 3, is negative 96 feet per second. Part C asks for the velocity when the coin hits the ground. So, we first need to find where s of t equals 0. We can solve this by setting our position function to 0. So, 0 equals negative 16 t squared plus 750. Subtract 750, divide by negative 16, and take the square root of that. So 750 divided by 16, square root of that, is about 6.84 or 85. Rounding to 2 decimal places. And then plugging this number back into our velocity function, it's about negative 219 0.09 feet per second.